Hello everyone, my name is Micah and this is my tutorial on how to get your software-defined radio up and running with SDR Console, Unitrunker, and DSD+. All of this software together will allow you to listen to what's called a trunked radio system. And the basics of a trunked radio system are you have some radio frequency range, right? So like, let's say this is a spectrum. In the olden days, in this particular frequency spectrum, you might have a certain amount of bandwidth allocated for channel A, right? And then you would have, you have a little bit of gap space so the channels don't overlap with each other. And then you have channel B, etc. down the line, right? You have all these different channels, and what you would have is you would have your analog radio. In order for two people to communicate, one person would tune their radio to channel B, so this or A, and this guy, so here, this my little stick figure, he would have his little radio and he would tune it to channel A, and so would his buddy down here on the other side. So these two could communicate. If this person tuned to channel B, he would no longer pick up the communications. Sort of how a CB radio works. This is also very wasteful because analog channels take up a bit of bandwidth. So the solution was to switch to digital channels. And specifically, a trunked radio allows for the reuse of a channel. So, for example, while this user is talking, this channel is being utilized, but as soon as they stop communicating, that channel is no longer in use. So a trunked radio system utilizes an additional channel that is a control channel. And the control channel issues commands out to the radios of the users and says, hey, as soon as you push the button, you are allocated a particular channel, and they are also allocated to a talk group. So, for example, where I live in Howard County, the trunked radio system has these particular talk groups. The fire department, the state police, the local EMS, even the shuttle service for the elderly that runs around here, they all run off of this one trunked radio system, but each of these groups, their radios are assigned to a particular radio group. Now, in this program that I have here, Unitrunker, we'll talk about it a little bit more later, you can go to a website called radioreference.com, and it will give you the frequencies for whatever trunked radio system is in your area. And you can then click this little button here, and using your credentials, log in and be able to download the schematics, if you will, or the channels for that particular system. So I can go here to, let's see, Maryland. And then in Maryland, you can choose a county. So you can choose Howard County. And they have a listing of particular frequencies here. But if you go down to the bottom here, you also see trunked radio systems. So the generic Howard County trunked radio system here is listed on this page. And it gives you this list of frequencies. Now, this particular frequency here in red is the control channel. And this is the channel that you would listen to pick up all of this data information. The rest of the channels are used sporadically, temporarily, to transmit encoded voice. It can be encrypted. It is not in Howard County. I believe the state police occasionally is encrypted, but most of these channels you can listen to anytime. So radioreference.com. There is also usually occasionally you'll find links where you can listen to these stations on the internet. So you do not have to actually have a system like this to listen to police radio. You can go to websites that have radio scanners and listen from your web browser. So that's radioreference.com. And what I am using to listen to these radio signals is something called a software-defined radio. And if you're watching this video, you probably already have one or are interested in getting one. But the one that I have is called a HackRF. You can purchase it many different places on the internet. I bought mine from SparkFun because I liked their website and they came with the antenna and everything. Um, I bought this sort of, you know, just on a whim. It seemed really cool to me because I was interested in radio. I've always thought about getting into radio, maybe getting my ham radio license. I saw that this was available, realized the potential for it, and went ahead and got it. But what I didn't realize is I could have researched and bought one of these. This is a TV tuner. You plug it into your laptop or your desktop, you plug this little antenna into it, and it allows you to watch television. But the magic of this little thing is that inside of it, it has a particular chip called an rtl-2832U. This chip will do the same thing that this HackRF does. The difference being that it has a slightly less of a bandwidth. It has the same signal quality, an 8-bit signal quality, but it's much cheaper. It's only $12. And it doesn't have quite the same range. The HackRF, you can tune pretty much from 0 hertz all the way up through, I believe 5 gigahertz is the rating for it. But if you watch the presentation by Mike Osmond, who made it, you can see that he's tuned all the way up to, I believe, 7 gigahertz with this without any trouble. Now, you do need an antenna. And I have purchased a few antennas for mine. They're not the best, so the signals that I get don't pick up the greatest, but a couple dollars here and there. At some point, I'll probably buy a better antenna. But I purchased this. It is this little 5 dB, 700 megahertz to 2600 megahertz antenna. I find this one seems to work the best for picking up my police radio around here. I also have this antenna stand with a cable attached to it. And this way, it has a magnetic base, so I can set it in my window, and it will stay in the window, and I screw the antenna to the top, and then it has a cable that I run into the HackRF. There's also another antenna that I have that works pretty well too. Here, I use this one to pick up other just random stuff. One of the things I'm interested in is, you know, Internet of Things devices, home security systems, messing around with key fobs, all those sort of things that you can do with a software-defined radio or in some of these unlicensed bands or in the 400-ish megahertz range. So this is a pretty good antenna. I also have this little stubby antenna here. Now, if you have all of the stuff, you might have better antennas. You might have the $12 rtl-sdr. Or you might have something more expensive, like a Blade RF or a USRP B200 or 210. If you do, that's great. This all works the same. Essentially, any software-defined radio will work with this. Now, when listening to police radio, when you look at the bandwidth of a particular trunked radio system, so for example, the Howard County trunked radio system goes from about 850 megahertz, I believe, all the way up to, I think, 863 or so was the highest signal. So you want to make sure that when you're listening to a trunked radio system, you can pick up the entire system. And the reason for that is the smaller, less expensive rtl-sdrs, the little $12 dongles, if they have a smaller bandwidth, say like 5 megahertz or so. I think it may be even 2 megahertz. When the voice channel tunes, if it tunes too far away from the data channel, it will move it, so you won't be able to hear that. So those are some potential problems you could run into. If you have 2, you can set one to listen on the data channel and set the other to be the one that jumps around on the voice channels. So enough of some of that. We'll go ahead and talk about how we get this set up. So I'm going to go ahead and stop this, and I will kind of explain a little more with my handy-dandy paint scheme here. No, don't save. So essentially what we have is we have our SDR radio, right? So we have SDR radio, and inside SDR radio we have things called VFOs. And you need at least 2 of these in order to be able to listen to radio systems. Now, the way this works is your software-defined radio can tune a broad swath of the radio spectrum. As you can see here, I can right now see everything from about 845 megahertz all the way through 865 megahertz. I get 20 megahertz of signal, which is a very broad slice of the spectrum, which is the benefit of using a software-defined radio. Now, in order for me to get all of these pieces of software communicating together, I need two additional pieces of software that are not necessarily hard to come by, but one of them, it's better to buy the actual paid version, and the other one is you can use for free. So there's a program that is called COM0Com. Let me type that out for you. COM0Com. And what this is it's a program that creates virtual COM ports on your computer. And why do we need virtual COM ports? Well, in order to control our software-defined radio here, we need to be able to send it COM commands. So COM ports can only be created by a driver, as far as I understand it. And what happens is we have VFO-A, and it is listening on a particular channel. It's listening on our control channel. And when it listens, it sends its data over to Unitrunker. So Unitrunker can decode this control channel here, this control channel, and it decodes and it knows what the different phone calls are to the different talk groups. Well, in order for us to listen to those talk groups, we now need to tune VFO-B. We need to tune VFO-B to pick up those talk groups. So what we do is we create a pair of COM ports. So those two COM ports, one will just be COM1 and the other one COM2, and they communicate with each other, right? So VFO-B will listen to this COM, and then Unitrunker will talk to the other COM port, right? And then these two COM ports can either be connected together using software, or they can be connected together with a port. It's kind of silly, but this is the way you have to have it set up. So the control channel sends signals, Unitrunker decodes those signals, and then tells VFO-B to tune to a certain channel. And if I hit play again, you'll notice that's what happens. The control channel will talk for a while. Eventually new calls come in. When the new calls come in, Unitrunker decodes them, and then it retunes this channel over here. And you'll notice sometimes there are multiple channels going on at once, or multiple calls. This is totally possible. What you can do is you can go in Unitrunker and you can actually set a priority, and you can say prioritize police over the garbage trucks, or whatever. And so that way when a police call comes in, it'll tune to that channel instead of tuning to whatever the most recent one is. The default behavior is to tune to a channel, listen until the signal stops. Once it stops, it will then go to whatever the next one is. So going back to our diagram, this is how this setup should work. There's a problem with this though. Unitrunker speaks a different protocol than what SDR-radio does. And I have an example of that. So how I found this out is if you try to get Unitrunker to talk to SDR-radio, it will not do it directly. Now if you go into SDR-radio and go to Tools, Program Options, Serial Ports, you notice I have all my COM ports set up. You can say Monitor. And I believe it's, yeah, and that's not the one we want, Test. So you can go into Test and you can say connect to a particular COM port. So I can say connect, they're probably all going to be bound. No, it's all going to be, so I can uncheck this one. So I go to Test, and I can bind to a port. And what this is actually for is it's to test out channel codes. So in order for Unitrunker to change the frequency of this, it sends it a message. And so you can actually click on this, and as a test, you can say like 840. That's too many. That's 8.4 gigahertz. We don't want that. 08454, whatever. So, and now I can say, let's change this to VFOB. I can say apply. And what that does is, if you notice, it's doing FB. So FB is for B. I wonder what would happen if I did frequency or VFOA. Well, if I do that, it says FA. Okay, so there's a pattern here. In order to set the frequency of this thing, you have to send it a command of FB and then the frequency. Well, the problem with this is the particular COM command that Unitrunker uses is not the same. So if I go look at Unitrunker, it doesn't actually tell you what the output is. And the way I figured this out is by actually writing a PowerShell script that sniffs the COM port and reads what it's actually trying to output. And some nice guy on a forum somewhere actually figured all this out, and he wrote a program called Unilinker. His Unilinker program translates from one to the other. And that's essentially what the script does. There's no need to do that, though. You can just do this in PowerShell. As soon as I get another signal, it'll actually quit. So there we go. So what we have is, if I look at this PowerShell script in Notepad++, handy dandy Notepad++, it's not incredibly complicated. I see what ports or what COM ports are available, and I print them. Then I say, hey, what port do you want to read from, and what port do you want to write to? That's pretty much the gist of it. Then I get those ports from the system. I say, hey, my Unitrunker port is going to be, whatever port, and my SDR-radio port is going to be the other one. And then you open those ports. This bit of code here I stole from the intertubes on a forum. It essentially allows you to press Q to quit. Although you have to wait until another signal comes through because this while loop runs. It's probably not the most efficient thing in the world, but it works. Now, what I do is I say message equals Unitrunker port.readline. So I read the message from Unitrunker. And Unitrunker prints messages with RF in the front. RF. Well, that's the problem. We don't want RF. We want FB, frequency of VFOB. So our messages should look like FB and then the frequency. So Unitrunker also prints a bunch of other messages that are useless to me. All I really want is the RF messages. So I say, if the message that I just read is RF, then we parse it. Else, we just keep going through the loop. The other problem is occasionally it tunes to a 0 frequency, which can be kind of annoying because when it tunes to 0, it makes my entire software radio system jump 850 megahertz back all the way down to the other end of the spectrum, and I lose my control channel and I have to reset everything. So if the message is RF000, however many zeros, you can wildcard it, then I do nothing. There's, again, probably a more elegant way to do this. Else, I create a new message where I put FB on the front, and I split the number off of the end. So it'll get, when I do this message.split, it's actually giving me this this part here, and which will be the actual frequency. And so FB with the frequency number is what we end up getting. I print that to the screen so that you can see what's going on, and then I send it to SDR radio. So that's all this does. It reads from one COM port, changes the first 2 letters, and then writes back to the other COM port. It's not really complex. Now, and when it runs, it just prints out the frequencies as they're being fed to me by Unitrunker. So when I run this, you see I have 4 COM ports. I know because of the way I have it set up that I need to read from COM port 3, and I need to write to COM port 2. And that's how my particular system is set up here. Now, why do we need these COM ports? What are these COM ports? How did you set the COM ports up? Well, I use a program called, where did it go? Virtual COM port driver. This company, NetBurner, makes a series of software and hardware devices where you plug them into an Ethernet port and they translate into a COM port or vice versa. And they have some software that gives you this nice GUI for like setting up a TCP server of COM ports and all that. But they provide this virtual COM port driver for free. And the reason that I prefer this over that other program, COM0Com, is the COM0Com driver does not work well on Windows 7 and after. The driver is signed by a development license or development certificate, so you have to disable driver signing on your computer in order to install it. For those of you in network security or computer security in general, you will realize that disabling your driver signing is sort of a bad thing. You're likely to get malicious drivers or rootkits or whatever installed on your system, so you do not want to disable your driver signing. Virtual COM driver does the same thing as COM0Com. It also uses your network stack as well, and it has a valid signed driver, so it installs nice on Windows 8.1, which is what I am running here. So there's that. So in order to set this up, you will have your virtual COM port. So virtual COM port, and I have 4 ports set up. And the reason for this is I need to be able to write to one port, read in, and then write back out from another port. So I have COM1 listens on port 5001 on my network stack, and then COM2 is a client that connects to that. So these 2 COM ports together make a single connection. Then I also have COM3 and 4, which do a similar thing. COM3 is a server on 5002, and COM4 is a client on 5002. So what have we done here? What have we done to set this up? Well, in the past, before, where we had one COM port connected to another COM port, we realized that this will not work now. We cannot have this. This is not going to work. We will have to, have our eraser. Where is it? I am not a super awesome person at Paint, as you can tell. So this will not work now. We cannot have Unitrunker talk directly. It doesn't work. So what we do instead is we have a pair of COM ports that are connected. And the same thing over here. We have another pair of COM ports that are connected. And the reason you have to do this way is one COM port listens and the other COM port can talk. And then we have my script. So you have the script here. And it communicates, it translates. So the script was listening on COM3 and it then writes back over here. So these are COM1, COM2, COM3, and COM4. So Unitrunker writes to COM4, which is connected to COM3, and then my script reads from COM3. It changes the data around, writes back to COM2, and then SDR-radio is listening on COM1. So that's how this system works here. Now, this is not the end of this. We have another piece of software that we have to utilize, because in this current setup, you can just say audio out, and then Unitrunker will listen to audio out. Well, the problem is you need multiple audio sources in this setup. What you need to do is install another program, and that program is called Virtual Audio Cable. And what Virtual Audio Cable does is it allows you to set up multiple virtual audio cables, just like it says. There is a free version of this. I believe if you read the forums, read around, the free version occasionally overlays some custom audio into it, so it doesn't really mess up much. It doesn't. It won't really hurt the trunked radio system, so you could use the free version. It just occasionally it might interrupt one of your signal decodings, which is kind of annoying. The paid version is definitely worth it. I mean, I don't think it's that much. I lost where the the price is. So yeah, they have different technical support levels you can buy online. It's worth it. Somebody took the time and effort to actually fix this product. It says $35. There is a link. You can come from somewhere else. There's like a link on the rtl-sdr forums where it's like 15 bucks or something. So you can get it that way. But it's virtual audio cable, and what it does is it gives you the ability, here we go, to create multiple line-in audio sources. So if you go down to your sound and you say recording devices, and I scroll down, you'll notice that I have line 1 and line 2. And what these are is they're virtual audio cables. Just like you would be able to plug in audio into the back of your computer, or so here's a real line in on my sound card. It creates these virtual lines that you can then transmit audio through. And you can create a large number of these. All you need is 2. And what they're used to do is to send the audio signal back and forth between these different programs. So I have my 2 set up. And what happens is the audio from this channel you use for line 1. So if I go to my audio settings, I go playback device, you'll see that I'm using line 1 as my audio out. Then when I come over here to my Unitrunker and I actually look at my receiver, I am listening on line 1. So unlike the COM ports, you can use these line 1 directly to line 1. So then my other VFO, the one that is listening to the voice channels I am sending that one to line 2. Okay, because if you listen to this, it sounds horrible. We can take a listen to one right now. Actually it's muted, but I can turn it up. If I change this, it just sounds like a horrible grinding noise. You don't want to listen to it. But the audio from this gets fed into this other program we haven't talked about yet called DSD. And DSD is a wonderful, wonderful program that is used to decode all sorts of digital voice. It's a great program. Shout out to whoever wrote it. I don't really pay attention to those things and I'm horrible with names, but it is pretty awesome and they should be thanked and given many back rubs. Let's go back and let's see actually what we have here. So I'm gonna do a new one. Don't save. So starting over, we have SDR radio, and our SDR radio, I'm gonna draw it like this. Our SDR radio has 2 separate tuners, if you will. It has an A and a B. So we're gonna stick with drawing these because. So we have A and B. So A has some audio, and that audio has to go out to Unitrunker. So we have our program Unitrunker. So our audio here, our audio goes over to Unitrunker, and Unitrunker decodes it. Well, Unitrunker needs to tell the other tuner to retune, and that doesn't work so great, so we use a pair of COM ports. We use our 2 COM ports, and then we use our script. We'll do a diamond for the script. 2 COM ports that talk to our script, and then our script utilizes 2 more COM ports to talk back. Whoops. Uses 2 more COM ports to talk with our other tuner, right? So this is how all of that communicates, right? So we have our COM ports here and our translating script in the middle. You can also download Unilinker, which is like a Visual Basic program that somebody wrote. Now we have retuned B. So our audio out from B goes into this other program called DSD+. So DSD+ is able to decode the signal, and then on DSD+ we can send the audio out to our speakers, right? We have our, we can say, hey, send this to our speakers. Let's do a cool speaker here. This is, I want to move it. How do I move it? That's okay. Anyways, we have our cool speaker. We have our audio that blares out of our speaker. I know that looks like Sputnik, but DSD decodes it and sends it out of our speakers. So that's pretty much it. And all of our radio signals come in from our HackRF. So we have our HackRF or whatever software-defined radio. So some sort of SDR, and our SDR then goes and feeds our data into this. And that's essentially the gist of it. That is how you set all of this up. And the end result is that you can hear radio.
Waiting for you to operate close to station. I'm someone over there. 75 APS.
75 APS at 2015.
Drop on cancel 31 0. Probably next to 314. Cancel 1 direct. Number 41. 241. On decap and then from this 1 to 937 Road, Baltimore.
And that's about it. The majority of this information comes from this tutorial. I'm not sure who wrote it. I don't actually see any names anywhere. It's linked off of the rtl-sdr website, but it has a lot of the same information on configuring your audio cables. It uses that COM0COM program, which you can link comms directly together, which is pretty cool. That would work pretty great. Unfortunately, like I said, COM0COM doesn't work very well on Windows 7, Windows 8, Windows 8.1 because of the driver signing issues. And then it also tells you how to set up Unitrunker. Unitrunker has changed a little bit since this tutorial was made. All of the settings are not under one tab now. When you create your radios, you have different tabs. So if you just click between the different tabs, you'll be able to get all of the different settings that you need. DSD is pretty straightforward. It's just an exe that you run from command line. The only arguments you really need to give it are what is the input audio source and what is the output audio source, which you can specify with TAC-I and TAC-O. If you run it without any arguments, it will tell you all of the audio sources, and you use the numbers that it tells you. This tutorial was meant to be used with SDR Sharp, which is another program that you can utilize. SDR Sharp is pretty awesome. It comes with all sorts of robust plugins that allow you to do all kinds of cool things. I tend to prefer SDR Console. This version 2.3 is a beta build, and it allows you to use CUDA, which is NVIDIA's GPU compute software, and what that does is it allows you to compute these waterfall displays very quickly without having to utilize any CPU. I use about 9 or 10% of my CPU shooting this, and that's with recording video and everything. So it is a pretty easy to use. You can also have multiple VFOs if you want to tune multiple radios at once. Where do you set that up at? Somewhere in the settings here you can configure multiple VFOs, but maybe in the options, I don't know. But there's a bunch of them that you can set up, and you can change the colors around and things of that nature. But that's pretty much it. That's setting up a trunked radio system using SDR Console, Unitrunker, DSD+, virtual audio cable, and virtual COM port, I think is what it was called. Yeah, Virtual COM port 2.0 is the version that I'm using. That's it. Thanks, guys.